G'day there. You're watching the Aussie BIM Guru, and today we're having a look at how we can take some cost-based data out of Revit using Dynamo and extract various types of quantities depending on the way that we want to measure these objects. Now I am going to be using a model I've already set up in the previous video where we've told Revit the specific cost rates and groups to sort things under. Now Dynamo has these available, which will really help us take advantage of this data in a future report, which we're going to do in Power BI. Now I did take a lot of inspiration from a similar video and workflow that was shown to us by the Revit kid, Jeffrey. So I do want to thank him for sharing his workflow. In this case, I wanted to go in a lot more detail in a similar workflow and show how this could be achieved from Revit to Dynamo to Power BI in full detail effectively. Anyway, if you're not already using the model from the previous workflow, you can find one on my GitHub at Aussie BIM Guru on GitHub under the Revit repo. So feel free to use that if you like. But effectively, we're just working with a reclassified Autodesk basic sample project. Anyway, let's dive in. So this is quite a lengthy process. It's going to go through a few steps. First of all, we're going to write the cost of objects on an instance basis. We're then going to create a script that will take some Excel data out of Revit, and then we'll feed this into a Power BI report so we can visualize our cost and quantity data. So in this case, I would recommend you do watch the previous video. If you haven't, I've already added some custom data to this model. For example, each object has a itemized cost instance parameter that we're going to generate, and this is going to be based on a relevant quantity times its cost, which in this case are type properties. So you might recall, if you have seen this, that I have populated them into cost groups, but as well as this, I've also informed them of the rate to use when they're measured by Revit. In this case, we're going to use Dynamo to use this rate to determine what the correct parameter is to read. Otherwise, we'll be using the cost and also associating a description. So you will need all of this data available in your model in order to undertake this exercise. So I'm going to begin just by jumping into Dynamo. So in this case, we're just going to be trying to build a script that can effectively populate all our cost data. So I'm just going to begin by saving this script, and I'll just call this whip script. And this is one of two scripts that we're going to build. So I'm going to begin by going to a view where I can see all the elements that I wish to cost. Now you can collect your objects by category if you want, but if you're in a small model like me, the all elements in active view approach is probably quite safe. So this is going to give us all 492 elements that we can see in the view. From here, I'm going to be getting the elements type. Now, if you're in an earlier version than mine here in Revit 2022, you might need to use a package like Archilab or Orchid to get an elements type, or the get parameter value by name node, but I'm just going to use the element type node instead, which is in Revit 2022, which also gives me the type. So we're going to work with both of these things to access and filter using various type and instance-based parameters. I'm going to begin by firstly targeting my takeoff rate parameter, where it says meters squared each, linear meters, etc. I'm going to use the get parameter value by name node, but in this case I'm going to apply it using a function because I know that some objects are going to have a null result, so I'd rather bypass generating a warning with this. So I'm going to use the function apply node, and in this case my argument is my element type, my function is going to be this, and I'm also just going to query my cost rate parameter, which is abg underscore takeoff rate. And what this will do is allow me to generate null values in the result, but it won't trigger a warning. Just a little bit of a trick I like to use. We can now check if the objects are null and also if they are empty, because some objects don't have a cost parameter and we want to filter out both of these object types from our study. So I'm also going to say, is the value equal to nothing, or an empty string? I'm going to combine these in an OR statement so that I'll get a true if either of those are true, otherwise I'll get a false. So we know that all we want to continue with is the false elements that we get. So in this case, I can get a filter by Boolean mask, and mask in this case my original elements, not their types, based on this. So we'll see some objects that don't have a cost associated to them. For example, curtain grid lines, things that I ultimately chose not to cost, things like pile threads, or pile rods you might call them, the topography, so various things that we're ignoring here, but we are proceeding with our out list. Now rather than go and get that parameter from the type all over again, I'm just going to filter the value list instead. So I also have a list of parameters in the out list that are parallel to these elements at the same time. I'm now going to separate the results based on whether they are of an each rate, because in this case, the each rate will just be the cost of the object. So I want to, in this case, make sure that I get that parameter properly. So I'm also going to check for does the value equal each? And from my out list of cost rates, we're going to be hunting down the objects that are costed on an each basis. And then also filtering, in this case, the out list, so that we can take our data using two pathways. So I'm also filtering my values. And let's just firstly deal with our each values. So in this case, the objects in the in list. In this case, I am going to use the element.element type node to target, in this case, the cost parameter of that type. So I'm going to use a get parameter value by name node targeting cost. So now for each object, we effectively have its cost because it's measured on an each basis. So we only need to treat the object as its itemized cost. We don't have to times it by any other metrics. The rest of our objects we are going to have to deal with specifically. So the challenge at the moment is that we know the rates of costs that we're dealing with, which are meters squared, meters cubed, linear meter, and we know the parameter names that they correspond to, length, volume, and area, but we can't target them easily. So at the moment, what I'm going to do is remap a list of parallel indices to an equivalent cost rate parameter. So I'm firstly looking for three known values, in this case, LM, M2, and M3. So I'm building a list of these three values. And we also know the parameters that correspond to these, in this case, length, area, and volume. So at this point, we know that we can target these parameters by the matching indice that we find in the list. As well as this, in this case, we also have to divide our length by 1,000 to go to meters, and also our area and volume are treated the same. So I'm going to go 1,000, 1, and 1 as a list, and these will be our conversion parameters. So first of all, I'm going to use the index of node to find out, in this case, from this list, where do each of these elements occur. So we're checking for the out list for each one of these. And we can see we find corresponding indices that we can then use to get item index from other parallel lists. So from this list, at that index, we now have the corresponding parameter name that that cost rate applies to. Likewise, we can also get the rate as it applies in this case to whether it's linear meters, meters squared, or meters cubed. At this point, I am going to want to get the elements type as well. So I'm going to get another element type node so that I can get the cost parameter. So I'm also going to borrow these nodes and get the cost parameter of these objects, because we're going to want to multiply, in this case, this times our equivalent cost rate parameter that we now have the value for. Well, we don't yet actually. So what I'm going to do is use element get parameter value by name. And from these elements, we know that we're now targeting these parameters. So I'm going to target them as the parameter name. And we can see we've successfully managed to retrieve different types of parameter values in the same list structure as the original elements. Now I also do need to divide, in this case, that value by its equivalent divisor. And now we have the true and correct quantity to multiply our cost by for that element. So at this point, I actually know the cost of each object. Now we do have a couple of interesting results here. I do have a null in this case for one object. So I am, in this case, just going to replace null using a node from crumple. And in this case, I am just going to replace it with 0. Just for now, in case there are any errors, we're just going to write this as empty cost. And now we should have a cost that we can set for each object. If you like, you can also round the number as well, should you wish to keep your costs a little bit more uniform and even. At this point, all that's left to do is set the cost of our objects. So I'm going to use an element set parameter by name node, and I'm going to need two nodes. So one for my top pathway for my each objects, the other one for my bottom pathway for the non-each based objects. We know that the values are going to be, in this case, these two inputs that we've generated already, and our elements are going to be sitting back here in this Boolean mask, with the top path being the each elements and the bottom path being the rest. I'm going to be targeting my instance cost parameter per object, so abg underscore cost itemized, which is why we're not targeting the elements type. And at this point, I'm going to switch to manual mode before I set the parameter. Save my script and run. Now in this case, it looks like something, I've made a typo by the looks of it. ABD, ABG. There we go. And we can see we've successfully set the unit cost of all these objects. So for example, this roof knows its area, this tree knows its value, everything effectively that could store a value. In this case, some things won't because they're going to be in groups, but I can see that I have set this parameter to varies by group instance. So in this case, you can actually manage it outside groups as well. But you can see everything effectively has calculated its equivalent cost. So a very effective script at giving our model some meaningful data. Now let's have a look at how we can actually view this model in the Revit, this data in the Revit model as well, because we can now schedule this data as well. Let's create a multi-category schedule, and we're going to schedule a few different things. We're firstly going to want to sort by cost group. We're going to get the itemized cost and the takeoff rate. We're then going to get the unit cost, the description of the object, and the category of the object. And in terms of the order that we wish for things to fall in, let's say first we're going to go by category, then description, and we might just show the count of objects as well. I'm now going to show first of all the unit cost, the takeoff rate, and the itemized cost, and we're going to hide the cost group. I'm going to sort in this case, firstly by cost group as a header with a footer that's going to have totals and a blank line. I'm then going to sort in this case by category and description. I'm going to turn off itemize every instance so all things sit in rows. And what I might do just to be sure everything is definitely unique is I'm also going to add the family and type input and hide it. But I'm going to use it to sort my schedule anyway. So on the background, if we do have two descriptions that are the same, they effectively can't be the same row because they're going to have different families and types. You just won't see that difference. So other than that, we just need to make sure that everything that we are actually scheduling, in this case, has an itemized cost. So let's say the cost itemized, probably we'll just say is greater than 0. We'll OK that, and voila. We've got a very detailed and really easy to read cost schedule with full itemization, unit costs and rates, and itemized costs. Now we do want to add just a few totaling capabilities here. So we do want to take our itemized cost and calculate totals. And we probably also want to add a grand total at the end and just format some of these units as well. So I'm going to field format this currency field to 0 decimal places, dollars, and digit grouping. And we should also then have a bit of an easier schedule to read. Of course, I could do it for this column as well. But we can see here we have quite an easy to read costing schedule that as long as you run Dynamo is relatively up to date. And we can see our grand total is just over $600,000, but we can also see them broken down by the trade groups that we've nominated earlier. Now let's get this data out into Excel. That's probably the next step that we want to do. So in this case, I'm going to make another Dynamo script. This one's going to be a little bit more straightforward. We're really just getting a whole bunch of values and setting them. Now I'm just going to save this script because I'm going to keep a little bit of this script. So I'm going to make a second one. And in this case, I'm going to delete pretty much everything back to here. So I'm going to go to the point where we have the objects that we want to deal with. Now in this case, I am going to also add a filter by Boolean mask for the element type as well. So we have the elements, their types, and also their cost rates in lists. And we're now going to proceed to extract various parameters from these objects to build into a big list for Excel. So first of all, I'm going to use my get parameter value by name node. And in this case, we're going to be dealing primarily with, I believe, in this case, the out list. So we can see here we don't actually have any views, any elements in our views, so we do want to be careful there. So what I might do is just reopen the script, run it again so that we can work with the elements visible in the view. And in this case, we can see we've also filtered out these objects that don't have a relevant cost rate. So from the out list, I'm going to work with a few things. So from the instances, I'm firstly just going to get the itemized costs. So abg underscore costs itemized. and we should get our cost value. Now at this point, if you did have any errors in here, you may wish to filter, replace empty values, null values, or even filter out any values with irrelevant costs, because that might happen as people make changes to the model if you haven't run the Dynamo script straight away. But at this point, I'm happy to stick with this value. It's pretty reliable. As well as this, I'm going to get the category of the elements as well. And that will be returned, in this case, I believe, as a string. So we can go category name, just to be sure we've got a string, which we do now. And finally, I'm going to target a few different parameters from the type itself. So I'm going to, again, get a get parameter value by name node, but in this case, I'm going to be pointing to the type. So we actually are going to target a few parameters here. So what I'm going to do is create a list, and I'm going to reconnect that. So I'm going to start writing a list of parameter values. So first of all, I'm going to target the cost group. Next, I'm going to target the description. And I'm also going to target the cost parameter, or the unit cost per se. I'm going to work across each element, and I'm going to apply each list of parameters on the longest lacing basis, so that the result ends up being a list of values per element for the list of parameters. I'm going to transpose these into 3 lists so that they're in the same structure as these other lists of data as well. I'm going to start using add item to front or end. So in this case, to probably firstly the end of this list, I'm going to add the cost rates. So because I've already created the transposed list of lists, I should find that the other list will just neatly slide in at index 3. To the front of this, I'm going to add my list of categories. And then finally, to the end of that list, I'm going to add my itemized cost. And we should have a list of lists with equal length. So to this list, I need to transpose this list and then add a list of headers so that each column knows what it is. And when we bring it into programs like Power BI, it already has header data. So let's think about what we want to call these. So I'm going to make a list again. I'm going to say firstly, category. I'll just say group, so cost group. Description. In this case, this will be unit cost, rate, and total cost. So what I can do now is just add this sublist to the front of my data so that when I send this to Excel, it's going to come in nice and clean. I then need to make an Excel file, and I'm just going to make a new file, a blank workbook, save as to my desktop. And I'll just call this cost data. I'm going to point to this using a file path. And I'm going to be exporting to Excel in this case. So I've got my file path. I'm just going to make a code block and say I'm pointing to sheet 1, starting at column and row 0. I'm just going to feed in my data separately. I am going to overwrite, and I'm not going to write as strings. So sheet 1, start of 0 for both, overwrite and false, and then underneath this node, I'm just going to tuck in my data. And at this point, we should have effectively a script that can write this data to Excel on a repeated basis. So if I run the script, there we go. We can see we have all our data in Excel. Now, I usually like to make sure that the unit types have been received correctly. So I usually like to say my currency is currency and my text is text. I'll save the file. That way I find the data is better received by Power BI and it doesn't make any assumptions for me. So I'm now going to open Power BI and I'm going to get data. I should see a submenu pop up which prompts me to nominate my data source type, which is an Excel workbook, and I'm going to connect to one, and I'm going to nominate my cost data. It's going to prompt us to nominate the sheet. We only have one, and we can see our data is coming in quite neatly. It's recognized that our cost and total cost are in the form of numbers, so we are going to reinform that data in Power BI that we're dealing with currency. So in the data table view, in this case, the unit cost is going to be currency, and the total cost is also going to be currency. Now, each row here represents an object in Revit. I much prefer to put data into Power BI like this because Power BI is great at summarizing data, grouping it, and sorting it together. So rather than trying to make your rows look like a Revit schedule, you can actually keep all your data quite raw behind the scenes, and then group and summarize using the tools that Power BI offers instead. So I'm going to begin probably just by taking, in this case, a pie chart, a fairly classic visual. And in this case, let's just cover our pie chart by maybe a group. So let's say that our values, our legend, well, our legend is group, but then our cost is going to be our total cost for the values. And we can see our cost breakdown by group very quickly summarized for us, very efficiently, very easily. Let's also add some slices as well. These are great ways to break down our data. Let's firstly make one that uses Revit categories. And let's make another slicer. And in this case, we're going to use probably, we'll give ourselves the ability to go by group as well. And then finally, we'll add a third slicer, which we'll use to filter description. And these slices will all naturally respond to each other. So if I select casework, in this case, notice we have already limited ourselves just to specific pieces of casework. If I look at walls, I can see that my groups have immediately recognized I only have 3 types of groups available for walls. And then I also have various descriptions available as well. If I pick facade, you can see now I'm just looking at my SIP or my timber facade, which enables me to really quickly navigate my model. Now you can always disable these just to get back to the full data visualization. I might make this just a little bit wider. We could also visualize our data in an effective way using something like a bar chart or a column graph. So in this case, I might just pick a column chart. I believe that's called. Yep, clustered column chart. So in this case, we could look by Revit category or again by group. So in this case, I'll say my axis is group. And in this case, my values are costs. And we can see quickly our total costs summarized in a visual way. Sometimes this is easier to view than a pie chart, I find, especially if you're just trying to see the magnitude of each group of cost relative to other ones. And as we can see, there are groups that we'd expect to be quite small, like joinery and appliances, compared to our major groups like structure, facade, and interiors. As well as this, we could look at other types of visuals or scorecards. So we could always, in this case, take a card, and we can just make this the total cost in this case. So we'll say the fields are unit cost, sum, and we can see now we have a very quick card that tells us the total cost we're currently focusing on, which responds to our report as well. Maybe finally we might add a extra field, and I might just make a little bit of room for this somewhere in my report. Maybe I'll just put it here. I know that's really not a very nice location for it. But for now, that's probably going to be easier. Not going to spend too long laying this thing out in a pretty way. The cool thing about Power BI is you can pretty much put things wherever you want. It's up to you. You're the designer. The last thing I like to include is a data table that gives me a breakdown of what I'm actually looking at. So we can add, in this case, a lot of our fields. We can say, maybe firstly, we want to see group, category, description, unit costs, rate, and total costs. Now in this case, I don't want my unit cost to summarize, so I'm not going to summarize, but I do want to tally my total cost. In this case, I probably don't actually really want to see my group. I think that's in enough other places in my tables. We can see now we effectively have an easy way to view the data of the objects as we filter them. So if I'm just looking at interiors, I can see now that everything has limited itself to just what I need to see here. Maybe we want to look at just our walls, and there they are. We can see their groups and their costing, and it's very easy and quick to actually analyze the cost breakdown of the model in a much more visual way. So I know I've flown all over the place in this tutorial, covering a lot of things in a very short time. I do recommend, if you struggle to watch any of this, maybe try 50% watch speed on YouTube. I do sound a little bit drunk in that mode, but it is easier to follow me. Having said that, I hope this has been a helpful pair of tutorials to show you how you can effectively set up a cost and quantity estimate system using a Revit model quite quickly. So there we go. We now effectively have established a data pipeline from the model through Dynamo into a readable format in a program like Power BI. There are of course many platforms and programs and methods you can use to obtain quantities and apply costs to objects in Revit models, but I find the trick is usually getting the quantities out of the model and intersecting that data externally in most cases. It's very rare you'll get a cost manager that's actually using a Revit model, or that architects are the right people to be entering cost data and managing it. So there are going to be other ideas I might show on the channel in future showing how you can intersect other data outside of the model source itself, but effectively there are many ways you could take the workflow I've done and introduce some additional steps to intersect the cost rates with the codes, either in Power BI using some queries, or in this case also just by working with some Excel magic before you take it into Power BI. The point is you want to have something consistent like a code or a description that you know is always the same, for example a specified object code, that you can intersect with its cost data outside the model with a more appropriate data source. Having said that, hopefully this taught you a little bit more about how you can measure different quantities from the model, but also combine them into a meaningful report in a suitable platform. Anyway, if you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future similar videos. Thanks. Take care.